welcome to the course Business Analytics and Data Mining Modeling using R Part 2. So, in previous few lectures we have been able to complete our previous module, that is unsupervised learning methods. So, where we were able to cover two techniques, association rules mining and cluster analysis as well. Now, we are going to start our second module and the last module as well, which is time series forecasting. So, therein first we will start with first topic is going to be on time series, understanding time series and different components of time series. So, this is named as understanding time series. So, we will start with this one. So, the main in this particular module time series forecasting, we are typically going to focus on time series forecasting as such, and some other aspects of time series are not going to be covered in great detail in this particular module. So, most of the discussion is going to revolve around how time series forecasting is performed. So, let us start our discussion on this. So, time series forecasting, typically this is done by nearly all the organizations which are into analytics to support their business activities. So, how we can say this? So, let's have a look at few examples. So, some of the some of the activities, specifically the analytics task that these organizations have to perform are like this. For example, forecasting sales by retail firms. So, as we know that most of the firms which are into manufacturing something or producing something, sometimes they also have retail outlets. So, they would be doing this business activity as well, which is about sales, selling the manufactured products right, or units. So, in that process, if they are also into the analytics, so they would also be helped in this particular business activity if they are able to forecast sales, right, because they would be able to find out how many units they need to manufacture or produce or purchase. Purchasing of raw materials and other things would also depend on their forecast of how many units they would be required to manufacture or assemble or whatever format they do it. So, in that sense, forecasting sales would be an important analytics task for them to be able to complete their business activity in a more efficient manner. So, this is one. As with respect to forecasting sales itself, as I said, other materials, raw materials, other items or material which would be part of that producing or manufacturing production or manufacturing process would also their planning would also depend on this particular sales. So, because the market itself, the demand and supply aspect of market, that itself keeps on changing. So, depending on the kind of demand that is going to be there in the next year and the kind of share that a particular company has in that market, and whether they would be able to increase that share. So, if they think that they would be able to increase their share, they would like to manufacture a bit more to fulfill that particular demand. So, overall looking at the market demand, economic environment as such, manufacturing production environment as such, they would have to look at the kind of market share, the kind of percentage of the market demand they can fulfill, and therefore, accordingly they will have to plan their operations. For that, they need to find out how many units they need to manufacture or produce, and their plannings for other raw materials and other items would also depend on this. So, all those all these things that I just talked about, they might in a way depend on how what is going to be the forecast for next year. Sales forecast for next year. So, you can see this simple analytics task of forecasting sales by retail firms is actually have a multi-fold impact on other operations of those firms as well as their supply chain partners and other partners. Similarly, if we look at the second example, that is about forecasting reserves, production, demand and prices by energy firms. So, in the energy sectors, if we look at this, because the countries and the firms which are into producing petroleum products, so they influence, they control that supply of petroleum products and other energy products. So, therefore, for energy firms to be able to maintain their market share or even increase it, they should be able to forecast few things. For example, reserves that they have, the production, their own production, that they can plan out the demand in the market and the prices that they can that they can charge for their products. So, all these things they are so much dependent on market factors and other internal external factors, that if they are able to forecast, their planning and execution is going to be much better. They would be able to maybe there is a good chance that they would be able to increase their market share as well, or earn more profits or increase their revenues. So, this simple analytics task, if a company is into analytics and into energy domain, so their ability to perform this kind of analytics task would go in a great way in terms of helping their core business activities. Similarly, if we look at the third example, that is forecasting enrollments by private educational institutions. So, as we know, in our country, typically in government educational institutions, the seats are fixed, the number of seats are fixed. However, private educational institutions, they can always plan for this, and for them it is going to be a challenging task in terms of forecasting enrollments, the students that would be enrolling for the institute, because there is competition within the private this educational sectors, and the number of enrollments fluctuate year on year depending on the various factors, performance of the students belonging to those educational institutions, their infrastructure, their their ratings, and other things, right. So, because of this, their planning, their staff arrangement, infrastructure arrangement, all that is going to be dependent on this particular analytics task. So, if they are able to forecast this number, they would be able to plan out their other activities, other supporting activities in much better fashion. So, for them also this is an important activity. So, similarly, we can talk about other examples as well. For example, the forecasting tax collection by government departments. So, the next year what is going to be the increase in tax receipts, tax collection, that is important for government departments, because they also have to be ready with that amount of paperwork, or even if it is in digitized format, that amount of processing would still be required. So, for that, all that preparation and planning and execution, if they are able to forecast tax collection, then this is going to help their activities in a much improved manner. Similarly, we can look at other examples. For example, forecasting inflation, economic activity by financial organizations. So, there are various organizations which keep on forecasting different macro level economic factors about developing countries, emerging countries, developed world, and overall globally, and there is always a hype around these numbers in every space of our society. So, this is also an important activity, because this gives an indication to to the government and other organizations how the economy is doing. So, inflation, economic activity, forecasting this becomes an important element for these organizations. Similarly, if we look at the transport sector, so now this example, forecasting passenger travel by airlines. So as we understand that airlines, the kind of traffic that they observe keeps on changing year on year, and also within a year there are there are seasonal cycles. There are times where the there are times of peak demand, then there are times where there are off seasons also. So if they are able to forecast the passenger travel, then of course in that fashion they would be able to plan their other activities accordingly. Similarly, if we look at the last example in this slide, the forecasting new home purchase by banking and financial institutions. So if we look at this, if banks and other financial institutions are able to forecast the amount of home purchases, new home purchases that are going to take place in the next year, so accordingly they can do their budget planning and other core activities, planning of other core activities and execution. So if we look at all these examples that we have till now talked about, they vary across different industrial domains, and a firm's ability to be able to forecast these numbers with higher accuracy and reliability would go in a great way to help in terms of planning and executing their core and other supporting business activities. So that is the importance of forecasting time series, which is the topic of our discussion in this module. So let us move forward. So now we are going to discuss few other important aspects about time series forecasting. So let us start with the kind of data set that is used in time series forecasting. So here we are going to start with a comparison between time series data and cross sectional data, because this is going to give us a better perspective in terms of understanding how time series forecasting is done and how it is different from what we have learned in supervised learning methods and unsupervised learning method, where we were typically dealing with the cross sectional data set. So in previous modules, one module that was covered in the previous course, that is supervised learning methods, and the other module, that is unsupervised learning method, that was covered in this course. In both these modules, typically the kind of data set that we were using was cross sectional data. So now let us understand the difference between time series data and cross sectional data. In our previous course also we have discussed few aspects of different kind of data set. So you can refer to that particular video lecture as well. So let us discuss this. So in time series data, typically the data is about one variable and one subject. So this this variable is measured for one specific subject, and this measurement or these observations are recorded over a successive equally spaced points in time. So and each observation is on same subject instance. So if we talk about a particular index that is being measured, so that index is going to be measured in successive equally spaced points in time. And if we have data if we have those measurements for a number of for a number of points, then that would form a time series. Now if we look at the cross sectional data, so data is on many variables and which could be related to many subjects. So like in previous modules that we have discussed, in all the data sets that we had, the data was captured, data was measured, all the observations had many variables. So typically the tabular format we had, matrix format, data set format that we have used, and there the rows typically represented the observations and columns represented the variables. So from that format itself we can understand that there were many variables, and these variables were not necessarily measuring something about a particular subject, particular type of subject, but it could be related to many other things as well. For example, one variable V1 could be about a particular customer, the second variable V2 could be about the organization of that particular customer, the third variable V3 could be about the family about that particular customer. So, or some other activity that particular activity which the that particular customer or individual might be associated with. So, in that sense we can say that many variables are involved, many variables are measured in cross sectional data, and they could be related to different subjects. However, when we talk about time series data, it is typically one variable and it is about one subject, and the observation in time series data, as I said, it is a successive equally spaced point in time. What does that mean is, so one observation is recorded on day 1, the second observation is recorded on day 2, and third observation is recorded on day 3, or it could be one observation recorded for month 1, another observation recorded for month 2, month 3, or it could be one observation recorded for year 1, the second observation is recorded for year 2, third observation is recorded for year 3, and all these observations are on the same subject instance. So, the index it could be one index, or it could be inflation, or it could be a GDP number. So, for example, if we talk about the GDP number, so if we are recording it year on year, we could be recording it quarter by quarter. So, if we look at these when we say year on year, so those are equally spaced points in time. When we say quarter by quarter, so those are equally spaced points in time. And when we say each observation is on same subject instance, so GDP is going to be of a particular country. So, if it is the GDP, if we are talking about measuring India's GDP, so at each observation is going to measure India's GDP, and at different equally spaced points in time, year on year or quarter on quarter. So, that is what we mean in time series data. But if we look at the cross sectional data, as I talked about, tabular data format or matrix data format, where there are going to be so many variables on columns, and they could be related to different subjects. In terms of observing these variables in cross sectional data, so these are observed at same point of time. So, if we are looking at first observation, and this first observation is related to a particular customer, then customer's age at a particular point in time, and at the same point of time the income of the customer, at the same point of time that particular gender of the customer, same at the same instant of time, and the organization of that particular customer at the same instance of time, any other observed variable or perceptual variable that is to be measured for that particular customer, so all those things are recorded at the same point of time. So, all the variables that we have in the in columns, they are going to be recorded at same point of time. The second observation that we had would be on the second customer, and it would also be recorded at the same point of time, approximately roughly at the same point of time. For example, if we are going for a survey kind of data collection, so we plan to finish it within a limited time frame. So, the data on all the customer can be roughly said has been recorded at same point of time. So, we do not make such a difference in terms of time. So, each observation represents a distinct subject instance. So, as I said, when I talked about the second observation in the cross sectional data, I said the second customer, but when we talk about the time series data, it is not the second country's GDP, it is the same country's GDP that we are talking about. So, it is India's GDP which is recorded for year 1 and then year 2 and year 3. But when we talk about the cross sectional data, it is the customer once data on different variables related to different subject, then customer 2's data on different variables related to the same subjects. So, the subject instance is changing. So, each observation is representing a distinct subject instance. However, in time series data, it is the same subject which is India, and India's variable on India is that is GDP, which is being recorded at equally spaced points in time. So, successive equally spaced points in time. So, I think this would have given you a better picture in terms of understanding the time series data and how it is different from cross sectional data. Let us discuss a few more points about the same. If we look at the time series data, unit of time used to order measurements is to be clearly specified. So, when we say a particular time series and that time series is about GDP or India's GDP, then we have to it is to be clearly specified whether these numbers are annual, whether these are yearly numbers for GDP or whether they are quarterly numbers for GDP. So, that unit of time that is going to be used to measure a particular variable, that is to be clearly specified. So, this is one important characteristic of time series data. However, if we look at the cross sectional data, this order of measurements in time does not matter. So, when data on a particular customer 1 was recorded and when data on customer 2 was recorded. So, we are not looking at that difference in time gap. So, we are not really valuing this particular difference in time. However, there might be cross sectional data set where time might be being treated as another variable. So, you might have cross sectional data set where you have one column having the customer's status, another column having age, gender, other columns having data related to other important variables, and then you might also have one column saying year or some date or something. So, in cross sectional data, time can sometimes be, if it is part of the analysis, that variable is important for the analysis, then time could be just another variable in cross sectional analysis. Let us move forward. So, the kind of analytics task that we typically perform on time series data are of two types. So, one is where we analyze time series, which is typically called time series analysis. So, this particular task is typically descriptive or explanatory in nature. Then the second one is forecasting. So, as I said, this module is that we are discussing here is mainly we are going to focus on time series forecasting. However, some aspect of even while our discussion on time series forecasting, some aspect are going to be common with what we do in time series analysis. If we compare this with the cross sectional data and the kind of analysis that is done there, is two kinds of tasks are typically performed: classification and prediction. So, as we have seen in the previous course when we discussed many supervised learning techniques. So, there typically we were either doing classification or prediction. If we look at the the module first module that is covered in this course, the unsupervised learning method. So, there we had two more types of tasks where one was clustering, the other one was association rules that rules mining. These are the kind of tasks that are typically done in cross sectional data. However, if we look at the time series data, typically it is about the analyzing it, analysis task or the forecasting task. Now, one more important difference between time series data and the cross sectional data. So, for time series data, the main idea is to examine changes in the subject instance over time. When we are whether we are doing time series analysis or time series forecasting. So, the main idea remains this, that we are looking to examine changes in the subject instance over time. That is why India's GDP when we look at the time series data, it is being recorded at successive equally spaced points in time, because we want to understand or analyze the changes that are happening in this particular variable over a period of time. If we look at the cross sectional data, the main idea is there to compare differences among the subject instances, right. So, we are always looking to identify the relationship between different variables, association between different variables, or cause effect kind of the causal relationship between variables. So, there typically we are comparing differences among the subject instances, and that is why if we look at the data set that we typically use in cross sectional analysis, each observation is representing a distinct subject instance, and the generalization is on that particular target population, which is each observation is coming from that target population. So, different observation is representing either different individual or different firms or any other unit of analysis that could be there. Now, let us talk about the technological advances that have happened in terms of information technology and different advances and how they are impacting the time series data collection as such. So, nowadays as we are aware the data that is being collected it can be collected at different time scales because of the computer systems and the advanced technological infrastructure that we have nowadays. So, you can see stock data, for example, it is captured at ticker level. If we look at the purchase transactions, so nowadays when we visit retail stores, so they are being recorded at real time. So, now the kind of transactions that are there, so these can be converted into time series based on minute, day or week, because that is the advantage when you are when everything is being captured in real time. So, that time stamp is always going to be there, and therefore, we can always convert the data into any unit of time for any time scale. So, all this is possible because of the technological advances, because of the barcode scanners that we have when we visit retail stores, because of the automatic data capture mechanisms that are nowadays present in every walk of life. So, because of most of the things that we do, somewhere some kind of systems are involved. So, most of the things that we do are digitization has reached to that level that especially in the business context almost everything can be recorded in real time, and therefore, it is easy to collect the time series data and at different units of scales as well. Now, the another important time as we were talking about the impact of technological advances and the ability to capture, ability to collect time series data on at different for different units of time scale. And now, how do we decide when this ability is there, right? We can get any kind of time series for different even at different time scales. So, how do we decide which kind of time scale is going to be more suitable for our analytics task? So, choice of time scale is an important decision to be made before time series forecasting. So, there are certain factors which are important for this kind of decision. So, first one is as per the forecast requirements. So, if we talk about the different examples that we discussed at the start of this particular lecture, for example, forecasting sales by retail firms. So, we look at that particular example depending on the requirement. So, typically the way retail firms plan for their operations, if the planning is typically done for year on year, the annual unit of time, annual time scale, then probably the forecast requirements would also be year on year. So, you would like to forecast sales for the next year, right. But if the planning is monthly, then probably we would require sales number for our monthly planning, right, so that we can plan our operations accordingly. So, what is the requirement typically, that depends on the kind of industry we are talking about and the kind of firm which might have its own internal way of doing business processes. So, therefore, forecast requirement, the kind of unit scale that is to be used can actually come from there. Then the second important point is label and sources of noise. So, this particular point is more with respect to analytics expertise. So, depending on the level of depending on the time scale that we are using, the level and sources of noise can actually cancel out or can actually increase, and this will have an impact on forecasting power. So, for example, another point that is mentioned, aggregation of data to a coarser level can be used to average out some sources of noise. So, as we know, typically when we think about a time series, we can always think about a time plot where different observations they go up and down. For example, stock data, if we visualize this, then stock data will typically swing in cyclical fashion, up and down in that fashion. and we are looking to analyze any kind of time series data, and if we change the scale and if we aggregate, if we take it to a quad-cell level, then we would observe that some of the noise that we see, some of those swings ups and down that we see, they will cancel out, they will average out in a longer time period. So in that sense, the noise levels minimize, and therefore the forecasting power in a longer time period in that sense increases a bit. But the kind of forecasting that we require is also dependent on the kind of requirement that we have. So both factors have to be looked at, the kind of forecasting requirements that one has, and then the kind of level and sources of noise that are going to be there, and how they are going to impact the forecasting power of the models. So with this we will stop here, and we will continue our discussion on this in the next lecture. Thank you.